Very well. So far we just keep talking about if the solution of a differential equation is given to us. But how do we actually solve a differential equation? What is the method? So note that we have different methods for different classifications of differential equations. It's not just one method, unfortunately. We have a lot of different methods for different types of differential equations. The very first one that you're going to learn is called separable differential equations. So this is our question. How to solve a differential equation. To answer this question, we need to analyze different classifications of different differential equations. To answer this question, we need to classify differential equations. So the very first classification is called separable ODE. So classify. The very first classification of differential equation is the first order. The first order separable ODEs or differential equations. Okay, separable. What's the definition of a separable differential equation? Well, if you can separate dy and terms, expressions in y on one side, and dx, terms and expressions in terms of x on the other side, we call it a separable differential equation. Definition of a separable differential equation. A differential equation is called separable if we can write it as f of y dy equals to g of x dx. Okay. So what do we have here? We have a function, an expression in y multiplied by dy on the left hand side. Here you have multiplication and the operation between these are multiplication. You might get differential equations that are not written this way, but our job is to do algebra and try to write it in this form. We can write it as f of y dy on the right hand side, g of x dx. So when it's separable, how can I solve it? What is the solution? When we have a separable differential equation, to solve it, we take the integral of both sides. Then we either try to write it explicitly, y equals to, or implicitly, a combination of x and y's or the variables that you have. Then we try to isolate y, or write the solution implicitly. Okay, very good. We just learned about the separable differential equation. Let's put this in a box. This is your goal. Your goal is to take a differential equation. If you can write it this way, you call it a separable differential equation, and how to solve it, you take the integrals of both sides. Okay, give us an example. The first example is this. Which one is separable? The first one is, well, dy over dx is x squared. The second one, dy over dx is x squared over 1 minus y squared. So which one is separable? Guys, remember, you have to know the definition. You always follow the definition. It says, hey, simply do the algebra. Nothing calculus about this. It says, hey, all of y's on one side, all of x's on the other side. So let me do an algebra. So I'm seeing x squared on the right-hand side. How do I take dx and separate it from dy? Simple algebra. Let's multiply both sides by dx. Multiply both sides by dx. Pure algebra. So what do we get? You get dy equals to x squared times dx. Well, now take a look at the definition. It says y's and all terms in terms of y's are on the left. I have dy on the left. I don't have any other y's. It means that, hey, f of y was just 1, which is not important. On the right-hand side, I need to see a function in x. Hey, I have x squared multiplied by dx, which is just right here. Very well. So as you can see, it follows the definition. It satisfies the definition. So it is separable. You have a separable differential equation. Both forms are acceptable. What about the second one? Can I do a little bit of algebra? Have all y's on one side, x's on the other side? Yes. I have some fractions. I need to get rid of the denominators. I have dx on the left. My goal is for dx to be on the right. So multiply both sides by dx. Multiply by dx. If you multiply by dx, it becomes dy equals to x squared dx over 1 minus y squared. So far, so good. I have x squared and dx on one side next to each other. My only problem is that I'm seeing 1 minus y squared on the right-hand side as well. But I want this to be on the left-hand side next to dy. Algebra. Multiply both sides by 1 minus y squared. Well, what do I see? I see 1 minus y squared times dy equals to x squared dx. Hey, check the definition. The definition of a separable differential equation tells me, hey, you need to have all of your y's on one side. F of y dy. My f of y is 1 minus y squared, quadratic, times dy. I'm good with the left-hand side. What about right-hand side? Right-hand side, a function in x times dx. X squared times dx. Very well. So as you can see, It satisfies the definition, and it is a separable differential equation. Very good. Give us more examples. Okay, let me erase this and give you more examples and make it more interesting. Not all differential equations are well behaved, nicely written this way. You have differential equations that are combinations of different functions, variables. We are going back to intermediate algebra skills to double check how we can write them as separable differential equations. So, example. Which one is separable? Well, this guy, number one, says dy over dx is equal to y squared times x e to power 3x plus 4y. Well, okay. And the second one is dy over dx is y plus sine of x. Very well. Okay. So pure algebra. Remember that your goal is to make sure you have f of x dx on one side and g of y dy on the other side. All right. This is our goal. Well, take a look at this. First of all, I can multiply everything by dx and bring this guy to the other side, step by step. Multiply by dx. Okay, multiply by dx, your dy becomes, okay, y squared times x e to 3x plus 4y times dx. Okay, so far I have, let me just erase this part, f of y dy g of x dx. It's easier to write the order this way. Later on, when you take the integral, you see that this guy takes the constant. Okay, so dx. We're happy about dx. I have x here as well. Okay, not that bad. Everything looks good so far. I need to bring y squared to the left-hand side. So divide by y squared. Divide by y squared. Okay, if I divide by y squared, it becomes dy over y squared equals to x e to 3x plus 4y dx. Okay, I brought y to the other side, but my problem is that the exponent for e has a linear combination of 3x and 4y. I cannot have x and y on one side. Somehow, doing algebra, proper algebra, I should be able to separate these. Let's go back to algebra. From algebra, we know that if we have e to the power n plus m, it is e to the n times e to the m. Apply that here. So you get dy over y squared equals to x e to 3x e to 4y dx. Wow, look at this. I have x e to 3x multiplied by e to 4y. How can I get rid of e to 4y? It means that I have to divide both sides by e to 4y. So this is my last step. Divide by e to 4y. So what did we get? We get dy over y squared e to 4y equals to x, e to 3x dx. Follow the definition. dy function of y or an expression in y on the left, dx function in x, expression in x on the right. It satisfies the definition, so this guy is separable. The definition, so it is separable. This guy is separable. Very well. So if the question says, hey, find the solution of this differential equation, you have to take the integral of both sides. What about this guy? Can I separate y and sine x? You might say, well, I can subtract y from both hand sides. But if you subtract y, then you get dy over dx minus y. Well, it doesn't satisfy the definition. You might say, hey, I want to multiply by dx first. So if you multiply by dx, you're going to get this. dy equals to y dx plus sine x dx. Well, you make it more complicated than it was. Well, if you subtract y dx from both sides, you bring dx to the other side. There is no way you can separate these. Note that here you have a red flag. The red flag is the addition between y and sine x. There is no way you can multiply or divide to separate these two. So, not separable because of the addition between y and sine x. There is no way you can separate this, and if you try to separate this in any order, it's going to make it more complicated. It's not a separable differential equation. Later on, we're going to learn how to solve this type of differential equations. But this doesn't belong to the classification of separable differential equations. So now that we know how to distinguish between a separable and non-separable differential equation, we're going to solve one separable differential equation. So let's see. This example says, solve the following. Solve dy over dx equals to x squared over 1 minus y squared. Question, solve it. So when you see a differential equation, follow these steps. Step 1, which classification it belongs to. Again, later on, we're going to give you a lot of different classifications. So it's important for you to check to see which classification it belongs to. Which classification? So far, we only talked about separable differential equation. Is it separable? Then in step 2, apply the method. So for a separable differential equation, the method is taking the integral of both sides. So check to see if it's separable or not. Check if it is separable or not. How? Doing the algebra. You need to have all y's on one side, all x's on the other side. Algebra. Multiply both sides by dx and by 1 minus y squared. By dx and 1 minus y squared. So what do we get? We get dy times 1 minus y squared equals to x squared times dx. Is it separable? Yes, it belongs to the separable differential equation class. What's the method for separable differential equation? Is to take the integral of both sides. So now calculus says, well, the integral of 1 minus y squared dy is equal to the integral of x squared dx. Well, for the left-hand side, the integral of 1 dy is just y minus the integral of y squared is a third y cubed. This is the integral of the left-hand side, and the integral on the right-hand side is a third x cubed plus the constant of integration. Well, as you can see, it's difficult to isolate y. So what do we have? We have an implicit solution, which is a family of solutions of this differential equation. So we have an implicit solution for the separable differential equation, which is y prime equals to x squared over 1 minus y squared. Okay, we found the solution for this separable differential equation. Step 1, check the classification. Step 2, apply the method for that classification. We just learned about separable differential equations. The method of solving a separable differential equation is to take the integral of both sides.